Matrix representation for C2v point group. As we have discussed in the earlier sessions, E can be represented by a matrix, a C2, sigma yz and sigma xz are correspondingly represented by their own matrices. Now, suppose if you want to develop a group multiplication table, that is, if you want to develop a group multiplication table, you can use matrix as a source. That is, matrix as a source means two different matrix can be multiplied. For example, you know sigma yz and C2. Sigma yz into C2 is actually, that is a commutative law. You should see whether the commutative law is working. That is sigma yz into C2 on C2 into sigma yz. Both can be applied in a commutative way. That is a commutative way. First I should write the matrix for sigma yz and then I should write the matrix for C2. Both should be multiplied. That is, when you're multiplying this one, no need to worry about the non-diagonal element. Simply multiply the diagonal elements. Simply multiply the diagonal elements. That is, minus 1 into minus 1 is minus 1 into minus 1 is 1, and then 1 into minus 1 is minus 1. 1 into 1 is 1. That is, if you multiply that one, it is sigma xz. Similarly, sigma yz into sigma yz, the same case if you multiply, that is yz is nothing but it is minus 1 1 1 minus 1 1 1. If you multiply the diagonal elements, it is minus 1 into minus 1 1, 1 into 1 1, 1 into 1 1. That is, it is nothing but E, that is the identity element. That is the multiplication of two different vertical planes. Two vertical planes, you will retain the identity. Similarly, C2 into sigma xz and sigma xz into C2, that is, I can apply this one either C2 into sigma xz or sigma xz into C2. If you apply, it is minus 1 1 for C2, 1 minus 1 1 for sigma xz. If you multiply that one, that is multiplying the diagonal elements, you will get this matrix, that is nothing but a sigma xz. Similarly, I can perform for sigma xz and sigma yz and C2 into sigma yz. Both of you will get sigma xz into sigma yz, you will get C2, that is a commutative law, the commutative product, you will get C2. Similarly, C2 into sigma yz, you will get sigma xz. Now, if I write entire in terms of multiplication table, in terms of multiplication, this is nothing but a replicate of what we carried out in the earlier session. That is, C2v symmetry will be having this group multiplication table. That is, group multiplication table means we should write the product at the intersection of the row as well as a column. That is, E into C2 is nothing but a C2. Similarly, sigma yz into sigma yz is nothing but a E. That is, if you do sigma yz and sigma yz operation, it is nothing but a E operation. Similarly, you can get the remaining operation. This is nothing but by the use of a matrix in the group multiplication table. How can you adopt your matrix multiplication in the group multiplication table?